Hi folks, Mr. Long here. I'm going to do a screencast today on determining algebraic derivatives. We've already been doing a bit of this, but we haven't formalized it at all. We've just been kind of using our intuition from some of our observations. So here we go. What we're going to formally introduce today is what's called the power rule, and we've been using this for the last, frankly, a couple of weeks, I think. So all it says is if I have any function at all, f of x equals a times x to the exponent of n, the derivative of that, or the slope function of that original function, is I bring the n down, and it becomes n multiplied by a, that coefficient, x to the exponent of n minus 1. Okay, and that's called the power rule of calculus. So here are some examples, and just looking at the pointer. So here's our original function, 4x to the fifth minus x plus 4. And so we want to get the slope function for that, which is denoted as, if this is y, this is y prime. Well, I bring the 5 down to the front, it becomes a coefficient. Then I multiply that by the original coefficient of 4. 5 times 4 becomes 20. Then I reduce the exponent by 1. That becomes x to the fourth. As for this one, I can use for the negative x, I can use the power rule, but I find it a lot easier just to think again that this is a slope function. What is the slope of negative x? Well, if it was y equals negative x, the slope would be negative 1. And again, what is the slope of positive 4? Positive 4 is a constant. It doesn't have any slope. It's 0. Okay, so the overall answer to this is y prime equals, the first, we call this the derivative or the first derivative, we also call it the slope function, is 20x to the fourth minus 1. Again, we've already done questions like that. If you want to go back and go over things, you certainly can. I would encourage you to do that. Whoops. And now what we want to do, like pause it and go back. Now what I want to go over are what's called radicals, right? Roots. These can be a little bit more challenging. So what the general rule is for a root, so we're going to get the derivative or slope function of the square root of x. Now, what we need to do first always is represent any radical. A radical is a root symbol, right? As a rational exponent, a fractional exponent. So you remember from grade 11 that root x as a rational exponent is x to the 1/2. Now we just simply apply our power rule. Bring the coefficient of 1/2 to the front. That becomes a new, or that exponent of 1/2, that becomes a new coefficient. Then we reduce by 1. Now, what I want you to remember here is when you're dealing with fractions, life's made much easier. If you're going to have to do 1/2 minus 1, you just represent that as 1/2 minus 2 over 2, because what is 1 as a half? Well, it's 2 over 2. Okay, so then we simplify after that. We have 1x, or 1/2, but 1x to the negative 1/2 over 2. Now we rewrite as a positive exponent. So that becomes 1 over 2x to the 1/2 in the denominator. Final answer is to put it back into a radical like you started with. So what is x to the 1/2? X to the 1/2 is root of x, but it stays in the denominator. So now your derivative of root x is 1 over 2 root x. Here's one that's more complex. H of t equals 5 multiplied by the cube root of x squared. Again, what's our first thing we do? Rewrite it as a rational exponent. So anytime you have a radical, you rewrite it as a rational exponent. So that becomes x to the 2 over 3. Again, what do? 2/3 minus 1. And then 5 times 2/3. So 2/3 minus 1 is the same thing as 2/3 minus 3/3. 2/3 minus 3/3, which is going to leave us with negative 1/3. Now what do I have to do? Write that as a positive exponent. And I do that down here, and I write 10 over 3x to the 1/3, but my final answer needs to have a radical in it, not a rational exponent. So it becomes 10 over 3 cube root x. Okay, again, pause, go back. I'm going through this fairly fast, but if you want to, you can pause, rewind. Okay, now we're going to do negative exponents. So what we're going to do here is get our equation. Sorry about that.